Okay, and the main objective of this project is to get maximum acceleration, maximum velocity, spring constant, period, frequency, and other data. And the data is going to be from the app accelerometer. For the oscillatory motion, the formulas that we're going to use are going to be the position, velocity, and acceleration. The app gives us already this equation. Well, give us, but the equation that this equation needs to be as a linear equation. Well, linear data. Also, you need to remember that the app gives you W as revolutions per minute, and you need to change it to radians over seconds. So with this, and also you're going to use this formula that W is equal to a square root of the constant of the constant in spring divided to the mass. And to get K, that is the spring constant, you're going to use this equation that is the total energy. So you know that total energy is equal to potential energy plus kinetic energy. But in this case, velocity is going to be a maximum, and when velocity is a maximum, x is equal to 0. So automatically this term disappears because it's equal to 0. And at the end, you're only going to have this equation, these two parts of the equation. So this is going to be equal to one half of mass to velocity squared. And to get the velocity, you already know that velocity is equal to W times amplitude. So you only need to do this to get the velocity. Okay, this is to find K, that is constant spring. So you just need to isolate K, and that's all.
For the first project that was moved to make a machine that moves only in the x-axis, we use a mechanism that transforms circular motion to linear movement, like we can see in the photos and the video how this mechanism works. To analyze the movement of the first machine, we occupy an app called accelerometer that calculates the acceleration of the cell phone in the 3-axis. So we put the cell phone in our machine, make them move, and then all the information that the cell phone captures, we download it to the computer. With the information that we get of this app, we make graph about the equation of position. We deduce the equation of position, the equation of velocity, and the equation of acceleration. Also, we calculate the max velocity and the critical points of the graphs and all the variables of harmonic motion that we needed.
Now, just to identify all the factors in all our graphs, we are going to see here how our graphs are built. As you can see, this is the graph of position, this is the amplitude, and this is the time and the recorded time. So we only just graph a part of our data that we have collected. And here are all our data. This is only a part of it. So we graphed this, and as you can see here, the position, it's a minimum. And as I told you, when the position is a minimum, it means that velocity needs to be 0. And as you can see here, we also graph just part of our data to build this graph. And also this is the amplitude and this is the time. Well, this is the amplitude, the velocity, and this is the time. Okay, this is a function of time. Also here, but as you know, x is amplitude, and as you can see here goes to minus 0.1 to 0.1, so we can say that our amplitude is 0.1. And for the acceleration, okay, well, and now from here to the velocity, we also have here this thing. We are going to 0.8 to minus 0.8 to 0.8, so that means that is our amplitude in this graph. Because as you know, working with cosines and sines graphs, functions, sines and cosines functions. And as I told you, if the velocity, let's just wait, if the velocity is 0, the acceleration, is 0, if the velocity is 0, the acceleration needs to be a maximum. So as you can see here, this is our theoretical acceleration and this is our experimental, so we were not so bad. Also here we have amplitude. As you can see here, this is like 6.5. It's like 7.5, and here it's also 7.2, just like that. So all this graphic, it's also as this is the acceleration and this is the time. This is a function of time. Our recommendation to you about this project is that if you are going to do this project, please do it with an iPhone, because if you used an iPad, your data is going to be wrong. Because the iPad, the app in an iPad doesn't work well as an iPhone. And another recommendation that we give is to know all the theory that you will use for it, and also to know more about Excel, how to do graphs in Excel.